So thank you. Yeah. So let's see if I think if I do this, then I can make it. No, I can't even. Anyway, there you get it. That's coffee mug. If you go to alistaircoburn.com, I added a page called Everything Else, and in the bottom of everything else, you can find things like mugs and T-shirts and funny stuff like that. So yeah, we've got just this hour, and that's perfect. And I highly encourage if any of you want to program while I'm talking in whatever your favorite language is, and then with some time to explore at the end. I'll actually show you the code at the beginning, and you could just like literally go in and do it in your language, in your environment, see if you can replicate what I'm doing, in your own space while I'm doing this. That would be just great. So the thing is, hexagonal architecture is strangely enough, I'm in the patterns community and I've written patterns for like a lot of years. And it's a sad truth that it's one of the three worst names patterns in the entire pattern library. Where by the way, the top winner is written by Jim Copleen, who's one of the originators of all patterns, and he has an excellent pattern called Buffalo Mountain. And to this day, I don't know what Buffalo Mountain's about. Even when I read it, the name's so bad that when I close the book, I can't remember what the pattern's about, because the pattern is named after a hill near where he grew up outside of Chicago that was called Buffalo Mountain. And there's a graph inside his pattern that resembles the silhouette of Buffalo Mountain. And so that's why he calls the pattern Buffalo Mountain. And so nobody knows what the pattern is because you can't tell anything from the name. So that's him. The second worst is Eric Evans, who also knows everything about patterns and has one that's called anti-corruption layer, which is absolutely not what it is, and that causes a lot of trouble as far as I'm concerned. So it's the second worst pattern language name, pattern name, and the third worst is by me, also an expert in patterns, and it's called hexagonal architecture because it's got nothing to do with hexagons anywhere in sight. It was literally a shape that I made up, not a whole lot better than Buffalo Mountain, but it's a shape that I made up before I knew what the pattern was about. So I knew it had to be that way, and I didn't know what to call it, and I needed a shape, and it couldn't be a square, and it couldn't be a triangle, and it can't be a pentagon, and it can't be a heptagon, can't be an octagon. So therefore, it's a hexagon. It's just a shape. And so I called it hexagonal architecture, like around 1999 or 2000. And then 2004 or 5, I finally figured out what the little facets were all about. And it's called ports and adapters. And so the official name is ports and adapters. Hexagonal's a nickname. It's got great marketing pizzazz. People love it. And they always go, what's a hexagon got to do with it? And the answer is nothing. With that, I'm going to jump in. I'm going to show you slides. There will be code, and I encourage you to code. And now it says, sharing is not turned on. Please ask Eugenio to turn on screen sharing. Make me a co-presenter or something so that I can share my screen. Good, thank you. I have to hide the floating meeting controls or else I can't make anything work. And I do all of that. There we go. All righty, cool. So this is the talk. I guess I can do it in a slideshow format here that I give all the time. There you see it's called ports and adapters. And we'll just step through it here. So here's the point, right? With every pattern, you need to say what problem you're trying to solve. So there's a problem that we've got, which is that automated regression tests, database becomes unavailable, upgrade to new technology, linking applications together and protecting your code from leakage between the business and the IO, right? Those are problems. So what we're going to do is to create the application, and in my new way of talking about it, you make it like it's a component in a component library. It's totally isolated from the world. You won't put it in a catalog, but you could put it in a catalog. It knows nothing about the outside. It doesn't know what the technology is. It doesn't know what you're connected to. It just cut out of the world with a test moat around it. It lives in isolation. And when you do that, then you get all these good things that you can run automated regression tests, da 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 da. So that's the why we're doing it. And some people love it for the testing. Some love it for the anti-leakage. Some love it for upgrading technology. Different people have different reasons they like it. Okay, so here's the TLDR. Just write this code. Here's Java code for you. Take a screen snapshot of this, whatever you want. And what I love is I got all of it on one slide in Java on one slide. And we're going to start stuff from the right-hand side where there's a mock tax rate repository. And there you see all it's going to do is we'll just start off and say 15% fixed tax rate. We're just going to make life easy. We're going to do a thing for calculating taxes. So that's easy enough, right? So there's your mock tax rate repository, however you want to do it. Now, what we've got is that hexagon. Someone said Alistair's legacy is going to be that people draw hexagons instead of squares, and that's already happened. So that's my contribution to your life is you now have to draw hexagons instead of squares in your architecture diagrams. But it's got two interfaces, and because it's a component, as I'll talk about, it's got not only the API, which we're used to, we're going to call it for calculating taxes, and you can have different methods in there, but the one we'll go after is what's the tax on a certain amount. And we're going to have this hook thing, and that's like it's a chip. It says it's an announcement of the calls it's going to make. So it's not asking anybody permission. It says, we're going to make a call out on this interface. The interface is for getting tax rates, because it knows it's going to go to some sort of a repository thing. And we'll have one function that we insist on calling called tax rate, on an amount. And sure enough, that we write the mock tax rate repository to meet that demand, right? So there we are inside the tax calculator. We have the two interfaces for calculating taxes. That's on the left-hand side, or the driving side, as we call it, and there's tax on. And then we also declare, notice that we declare the interface for getting tax rates and declare that we're going to use this thing double tax rate for getting the tax rates. And notice that the fixed tax rate repository implements for getting tax rates. So that's the key to the whole thing. That is the only thing that's surprising. People say it's too complicated. That is the only complication, is that the app declares the interface, and all of your outside things, service providers, implement the interface declared by the app. That's the sticking point you have to get over. And that'll influence where you put your code, how you set up your projects or folders or modules or whatever. So you get the dependency independence that we're after. So that's it. So sure enough, then the tax calculator, if we look at the app, implements for calculating taxes. So our types are interfaces. And then when it gets a call to do the tax on, you set it up in the constructor, you pass it in what repository you want it to use, and that goes in the constructor. And then when you call to get the tax on something, it says, we'll use that, whatever that is, right? So it doesn't know. And now down at the bottom in main, there's actually two things going on that are not obvious. First, you have to set it all up, right? It's the wiring diagram. So first you have to go get yourself a tax rate repository and say it implements for getting tax rates. That's its type. And then you have to go get a calculator, and that's going to be called, the type is for calculating taxes. And in the constructor, you say, hey, yeah, use this tax rate repository. And those are what we call a configurator. Now they're in main typically, but they could be in Spring, they could be in some kind of a harness, they could be in your test classes, they could somewhere, but they're their own thing. It's called a configurator. We'll talk about that. And then finally, in main is we just use it, right? So you just use it. So those are the parts: the repository, the app with the interfaces, the configurator, and the use. So like 4 parts there. So that's it. So now I'm going to take this away, and now I encourage anybody to go grab your programming environment and code that up, whatever. So here's the thing. The benefits are you can set up, at initialization, you can set up the driven actors, right? So driving actors on the left side are driving the app, and the driven adapters are on the right-hand side. They're driven by the app, right? So you can change them in real time. If you have a long-running system, you're going to change your technology sooner or later. If you think how long Amazon's been running, Netflix, any of those things, they need to change, not just like, are we using, this or that SQL, but they go SQL, not SQL, I don't know, microservices, nobody knows. So you need to be able to update, change those driven actors, the repositories in real time over years. Then people who do testing, they don't mind. They're used to like changing the source code, recompiling and running the test, and then changing it and making it real. We don't want that. Replace your production connections with test harnesses and back again without touching your app source code. You don't have to rebuild the system every time. And then we'll get to this. Because of the test wall, you can absolutely, this is, I guarantee you, after decades of trying, this is the only way to prevent leakage of business logic into the UI or vice versa. This is the only way that I know of, that I've seen. So those are the benefits. The costs are, that people say, oh, it's too complicated. So these are the actual costs. You have to add an instance variable for each driven actor, or you can use a broker and get it every time, but there's some work involved there. You have to add a constructor parameter for each of the driven actors, or a setter function, or a call to configurator. So there's the load, programming load. You have to design and add the configurator, which you probably have half of anyway, but you have to do that. And then if you're using Java or a type check languages, you got two more pieces of labor. You have to declare the required interfaces or the driven interfaces, and you have to add folder structure for the port declarations. And I'll show all of that. But that's the thing when people say this is, oh, this is extra complication. Those are the complications right there. Personally, I think that's small for what you get, but your mileage may vary and so on and so forth. So I'm going to go short because of the time. I don't want to use the whole time just for the lecture, but basically I got hurt like in the 1980s because I grew up in Smalltalk and everything is interfaces. You switch between, my programmer was programming in C, and he tied himself to the GUI, and our first user wanted to take input from the network or a file instead of from the GUI, and he said, I can't do that. And I go, what do you mean you can't do that? And the second was in the mid-90s, so later, like 8 years later, they were doing this invoicing system. And first they tied to the GUI, and the client said, hey, we want to run from batch, and they went, ow. And the second thing is they had an SQL database, and they had to redo the mapper. And they shut down the project for weeks while they redid it. And I said, just give me a way to run my tests locally. And they said, no, can do. So that was when this all got started. I never programmed. I'm not a systems programmer. I'm an app programmer. And I worked, it turns out, it took me a long time to realize, I worked out this code and this design slowly over years because I got tired of being hurt that I couldn't get what I needed to get. So I worked this out very slowly. What somebody else has to do to give me what I need, right? So the app has to be constructed. The architecture has to be built this way. And the one that pushed me over the edge was my friend Mo had a weather system, and he was dying because he had connected, like hardwired, all the drivers, driving actors, and all the driven actors, and he was getting a combination of permutation, configuration, nightmare. And I said, why don't you just put APIs everywhere and you don't have this problem? And he looked at me like I had three heads. So that's when I said, okay, this is real and I need to document it. And that was around 2000. I'm going to go after this idea. It's a component. The point about if you buy a component, if you buy a chip, it doesn't know what you're going to connect it to. And the chip manufacturer tells you what the output pins are going to do. You don't get to have any say-so on what those output pins do. The timing, the voltages, the signals. It's in the catalog, and you design the rest of your board to deal with what the catalog says. You don't have any choice. So we're going to do that. And you see, thanks to UML, we get these little round lollipop shapes, and those are the input pins. And we get these hook shapes, and those are the output pins. And so if you had this as a chip, right? And what's cool about these things is now you don't have to draw a hexagon. I'll show you later. You can actually just use rectangles again. So you don't have to use hexagons. With these lollipops and these hooks, it's evident what are the input pins and what are the output pins directly from your drawing. So we'll take a look at that. Now, the application, the pattern, as I describe it, is symmetric. The pattern says the stuff on the inside, do what you want with it. The stuff on the outside, do what you want with it. The stuff on the inside's not allowed to know about the stuff on the outside. That's the whole of it, right? It's symmetric. I don't care driven driving. It just says stuff on the inside, stuff on the outside, right? So if you want to do layers, there's only two layers. The bottom layer is the app, contains all the business logic. The thing at the bottom is the thing that depends on nothing. It depends on nothing. It just sits there. Then everything else depends on it. So all the arrows are going downwards. Both, guess what? Both the repositories, the databases via their adapters are going down, and also, the driving things are going down. So it's two-layer. Now, when you go to implement it, because of the way software works, you always have to pass into the app like who the repository is going to be. There's no other way to do it. And the application never knows who's calling it. It's the way software works. So in the implementation, there's a difference. We've got left and right, in and out, driving, driven, right? I typically see three types of driving ports, those lollipops. There's configuring stuff. Not everybody has a configuration port. I like to have a configuration port. There's all the people using it, right? The different kinds of users using it. And typically there's also one for your admin, reset passwords and change permissions and things like that. On the outgoing side, the driven ports, there's three types again. We've got, like if you're sending message to an email system or a pager, it's a notification. So you notify people of this. If it's a repository, you're getting data back, and you may be controlling something. You may have actual machine things that you're controlling. And then by convention, and this is not enforced by any compiler, but it's our convention. We just happen to think it's very communicative. We name the ports for the purpose. So it's always for doing something, right? For configuring the app, for buying parking spaces, for monitoring parking adherence, right? For adminning, things like that, for notifying, for gating. Always do that. And if you're in Java, so your interfaces will be called, and in fact, as you saw it right here, right? If I just go here, for calculating taxes with some number of functions, for getting tax rates with some number of functions. Those are the, so we use that convention. Now here are the two pictures. I'll just flip them back and forth for a minute, right? So there's the app, and it's just sitting there on its own, and you're in a testing situation. You're dev, you're testing. You hook all test harnesses to all the driving ports, and you hook all, stubs and mocks and things on the driven ports, and now you just test it, right? Now you don't change any line anywhere in the app. You change it in you use different configurator, wiring diagram, right? And now you hook up. You might have startup, GUIs, different things, devices, databases, and so on. And that's the punchline. We don't have to recompile the app. We just use it, and we use the configurator to make those changes at runtime. Good deal. So there's Mo's, that hand-drawn thing I did at the beginning, and I drew it up. He also is getting other apps driving it, so he was really tearing his hair out over this. So you can see how many different technologies he's got driving the app, and how many different technologies he's using on his driven side for the notifications. In the development sequence, there's four. Highly recommend. See, number one is that purple one at the top. Always, always, always start with your test suite, your mock database. You get the app working. You can do all the kind of stuff with it. Now, what I tend to do second, typically I'll go do a command line interface or a form or something easy. Just switch the production driver, have to make a main, right? There's a fair amount of work involved in that. And then typically third, I'll go the other way around. I'll go from my tests to production database or a different database or some other kind of database. So now with steps 1, 2, and 3, I can flip back and forth and make sure everything's working on all sides, all the tests, all the switch, all the configurators working. And then finally, then when you go from a production driver to a production database, life's pretty easy at that point. So those are the 4 stages. Oh, what's cool is you can really do fine-grained incremental development with this strategy. And this is where you can see you stop the leakage of the business logic, the IO back and forth. Because if you're doing, 1, 2, and 3, if anybody leaked any IO stuff into the app or business stuff into the IO, the tests will break, right? So this is the thing that will guarantee that you never make that mistake. I jump over that one. So there's the tax calculator. There's a simple drawing. Now, I'll just make a little note about UML. I think we're coming up on the UML slides here. That hook, the hook and the ball. Let's see if I've got that one. Oh, this is I decided to show you for Ruby, right? I showed you for Java, and the Ruby code is much shorter because there are no interface declarations. And my colleague, Juan Manuel Garrido de Paz, has always worked with typed languages, and Ruby drove him crazy because there are no declarations. You can't see what the required interface is. You can't see what any of the interfaces are, and that drove him mad. Ruby programmers tell me, gee, we have a hard time figuring out what's the big deal here with hexagonal architecture, in Ruby, because we don't have all these type declarations you Java people are fighting over so much. So, but there it is. It's super easy. There's the fixed tax rate repository, and the tax calculator doesn't have to do any declarations. It just calls that, right? So there's the configurator. There's the constructor where you pass in the tax rate repository to use, and then you just say use it, right? That's the way it looks in Ruby. The configurator is still there, and the usage is there. So you can screen snapshot that if you like. Let's see here. Now, small detour for the type checking people and why there are these hooks and things. This doesn't matter if you're a Ruby Python programmer, you don't need these things. But if you're Java, C++, you absolutely. So UML came out in 2005 with these things, which I didn't know about because I was busy writing the pattern at 2005. If you see the ball, it only means that B provides services and A uses them. It actually doesn't say that B defines the interface. It only says that B implements the interface. Normally, on the API side, it also B will both declare it and implement it. But all the ball means is that the B is going to implement this interface and provide these services, and they can use them, right? So that's good. The thing that they added in 2005 that's essential for this pattern, as it turns out, is that when you have that hook, it says A defines and owns that interface definition. And so B can go ahead and implement it, but A owns it. Whereas the one on the left, you see that A has an arrow coming in. Kind of the implication there is that B defines and owns it. Whereas the one on the right, A owns it, defines and owns it, B implements it. So we're going to make use of this here. And I love this picture. Oh my God, this took so long to figure out how to draw. And my thanks to Juan for getting this, because I don't play this game. I'm a Ruby programmer. So there you see on the left, on the driving porch, you see that ball, the users relationship. There you see the app, and there you see inside of that folder, the app declares the interface and the app implements the interface using standard UML drawing. That's sort of how you think of things. The one on the right, again, is the one that's unusual. The component defines the interface and uses it, and the external system implements it, right? This is a lot harder to talk about than it is to type. That's why I show you the code. Just copy the code. So if we just break out from that first slide, just that piece right there, you see that the tax calculator defines and owns the interface for getting tax rates. And then the fixed tax rate repository depends on that and implements that. Okay, cool. And there's all of that like it was before. Just put it all together. Now, if I don't include the code from this, Juan did a much more complicated example. He's got 2 primary actors. You're in Europe. you're buying a parking spot. They have different colored lines on the ground. So like blue is one rate, red is another rate, and some other color, green is another rate. So depending on where you park in the city, and then you go on your app and you pay for that, and then a parking inspector can come and double check, right? So we've got two driving actors, and we've got a rate repository, we've got a permit storage and a payment system on the Driven side. And you can go to his GitHub and read his code there. It's pretty complicated as far as I'm concerned. But there you see, he called it for parking cars, for checking cars, for obtaining rates, for restoring permits. And he puts those on the inside of the hexagon because he wants to show that those definitions belong inside the hexagon, inside the app. Right. And then here he's got both testing and real. So the car driver gets a web UI adapter, and he gave the parking inspector a command line adapter. I don't know why, but that's his business. And there you see he wanted to make it like include everything. So he has a file interface, repository as a database, and he has a wallet. Go check out all the code, but just how it looks when it gets a bit more complicated. Here's where it matters is where you set up your folders and your projects. So this is super important. It's not part of the pattern. You can do anything you want, but I'll tell you, when I visit people and they don't have the folder set up this way or the project set up this way, it's wrong every time. So these days, I walk in, step 0, set up the folders. Step 1, make your first line of code, right? So in the ports, he has 2 folders, driven ports and driving ports. I will say, footnote, and I haven't updated this slide, a lot of people find driven and driving too similar and confusing, and that's fine. People are using inbound and outbound. So driving is inbound ports and inbound adapters, and driven is outbound ports and outbound adapters. If you choose to use those words, no problem, doesn't hurt me at all. So in the driven port, this is where most of the difficulty is, right? The outbound port. There he's got his interface for obtaining rates, and then he's got a set of methods. Down in his adapters, the driven adapters or the outbound adapters, there's his adapter that implements it, and it goes on for a while. I just showed the first line. So set up your folders that way, right? So here's just one picture, driven adapters and driving adapters outside. The adapters are outside the app. That's the most important thing. And then 3 folders inside the app, the driven ports, driving ports. And so they're all inside. Now, I will say again, another note, there's been a lot of conversation around this. Some people write to me and they say they don't like the port definitions inside the app project, and they'll make a whole separate project module or folder for it so that both the adapters and the app refer to the interface definition. They find that has a better decoupling. Your choice. I think it's a good idea, but different people have different styles, so choose that one as you like. Again, screen snapshot this, replay the recording, because I'm going pretty fast here. I want to get done and get some conversation up there. Now, the configurator is an interesting thing because it's officially outside the pattern, because the pattern says just set up your interface. But you can't do anything if you don't have a configurator. So there's 2 kinds of configurators. You have the one on the left and the one on the right, and I'll walk you through. And then you see the nice thing with that hook and ball. It's a component diagram in UML terminology. So you make the app, it's got the hook, it says here's an interface. And the ball means any of these 3 things can hook to it. The mock repo, repo B, repo C, whatever you want. So it's a nice way of showing that you could have different things hooked to that. Now, the usual way of doing the configurator is inside the constructor, called dependency injection. It's one way to do things. I don't happen to like the word dependency injection. It's probably 4th on the list of badly named things because the word dependency is misleading. But in any case, doesn't matter. You have a method called, you want to set the tax rate repository, and we saw that before. So that's just normal. You say tax calculator new, use this tax rate repository, and the tax calculator squirrels it away. I hope that's clear. because we've seen the code for that. So that's pretty standard, pretty normal. Just to be clear about it, there are times when you want the tax rate repository to be dynamic. And I like tax rates because let's just pretend different countries have got different repositories with different structures, maybe, or maybe you get a live link to the country's actual tax rate authority. So now you've got not got a repository, you've got a hot link that you're going to use. So for every different country, if you're going international, you might have to look up which tax rate repository to use on every single request. Now, at this point, you don't get to have just one tax rate repository. You're going to have what they call a broker. So you have a rate repository broker, and then every single call, you'll ask the broker, given this country, which repository should I use? Okay, so that's a broker. Now we've got a recursive problem. How are you, because the rate repository broker is now an external repository. It's an external actor. It's a driven actor. We're going to have to test it, and we have to use the same pattern. So probably you're going to use dependency injection and a constructor to set up the rate repository broker. So you'll have the test broker and the production one, and then you use the broker for your test repository and your other repositories. So that gets a little bit hairy. But if you're in the broker business, you sign up for that. Getting near the end, just a couple of things to wrap it up. There's the ports and adapters. The insight, the strange thing for people is normally when they say the system, they include their adapters. They have a web UI. Your UI is an adapter. It's not part of your app. And don't put your business logic in there, right? And your command line adapter, people consider that's part of the app. Your SQL wallet adapter, they draw the circle where the blue thing is. And we have to get away from that. All those things are outside the boundary. The boundary is where that yellow, right, with the magenta business. So the real ports and adapter boundary is inside all of those adapters. I don't want to go through costs and benefits again, but there it is. There's the pattern of the thumbnail with the weather warning system. Create your application to work without either UI or database so that you can run automated regression tests against the application, protect your code from leakage between business and IO, work on the database becomes unavailable, upgrade to new technology, and link applications together. Now, what I want to show you is I've just added these two. People like these two drawings, so I'm gonna show you. People always go, but how does that look in a layer diagram? Where's the layers, right? And we've gone, oh my God, we spent so much time trying to draw the two-layer diagram, and it kills us because it's nearly unreadable. But let's just say here, this is like in my motivating stories on the left, there's your standard three-layer architecture, the way people draw it. You have the GUI, has a compile time dependency on the invoicing system. And our invoicing system has a compile time dependency on the database. And it's a compile time dependency we don't like. That's what we're cutting right there. So what we're going to do is put the invoicing system at the bottom and have both the GUI and the database dependent. Now, the problem is you're going, but I bought an SQL database. I mean, I've got whatever I've got. I'm not going to make that dependent on the app. That can't work. So that's where the adapters come in. But here's a little bit the thing that's counterintuitive. We're used to execution straight top to bottom. And now, because we got the things dependent this way, the execution goes against the dependency, right? So the compile time dependency is this way, but the direction of execution is that way. And blow this out. This is the last slide. I'll blow this out. People find this kind of convenient. There's your three-layer architecture on the left. Since people think of the adapter as being inside what they call the system, the adapter's inside the system, the business logic depends on the adapter. The adapter knows the database you're going to use, obviously. And so you've got this dependency and the direction of execution. On the right, and again, feel free to screen snapshot this, look at the right-hand side. Notice the ball, that hook is going up. right? So there's the invoice system declaring an interface. Now your adapter, your database is purchased, right? It's also a component. It's not gonna, you don't get to change its interface. So it's got that ball, right? So it's declaring and owning its interface. The interface voicing system is declaring and owning its interface. Your adapter has a dependency on both, right? But it's outside your system proper. So that's how you get it so that the dependencies, look at that adapter, the dependency goes up to the database and down to the invoicing system. And that's how we get our dependencies to look the way we want, and the direction of execution is that way. So I do believe that's the end of the story. So I'm gonna stop share and come back and see what we get in terms of questions and conversation. My first one is, did anybody code that up while I was talking? I would love it if someone says, yeah, I got some code for you. Or were you all eating peanut butter sandwiches?
I'll bet you most of them were like eating something. I was drinking my shake. Um, but this was excellent presentation. I gotta say, this is very clear. Um, we'll post this up, and I'm telling you, this is very helpful.
Well,
Um,
I don't know. I mean, if you just drank a shake that left you about 30 minutes for typing, I don't know what you did. Daryl, gimme what you got, Daryl.
Well, I mean, my main question is, how the reality of the world is that there's frameworks out there. And I'm kind of curious how something like Spring Framework or Spring Boot's method of architecture, kind of
They all
fits
do
into
it, man.
this.
They all do it. Just use them. I mean, the first time I needed to program this up in 2005 and get some sample code, we used Spring. It's just all there.
Mhm. So it's one in the same, one in the same, you're saying.
Well, they implement it. I mean, I suppose you can find a way to not have. Here's where the problem is that most people run into, and I've had to add just a couple of sentences in the book as I'm modifying it. There's, let's say, a weak implementation of the ports and adapters architecture and a strong implementation. And the weak implementation, it's going to be an SQL database, and your app boundary, you you know that it's SQL and it calls SQL, and in your Spring framework, you put in stuff that knows about SQL. Well, it's correct. You've got the instance variable, you're making the call. You are, however, still dependent on SQL. Your mock repository has to implement SQL language to give it back. So you've technically implemented, but you haven't really gotten to the heart of the matter yet. So the full implementation is if you don't even know about SQL, you don't know that the domain speaks in domain language. I need to know this tax rate. I don't know where it comes from. So the component speaks its own language naively. And then so you have to, when you use the framework, you have to put that into the framework, right? You have to declare what is the interface for your app, and then you use your Spring or whatever your favorite framework is. That they all do. They've been doing dependency injection since forever, right? In fact, I think Spring came up with the name dependency injection or something like that, right? So yeah, you're safe. But watch out for that that thing that I would say most programmers fall into the trap of knowing it's SQL. And yeah, you get away with that for a while, but then suddenly one day it's not SQL, and you're back at the beginning again. There's no extra cost for making it independent of SQL. Does anybody else have a thought, question, comment?
With the folder structure, so for the adapters, I mean, I guess do you encapsulate everything under one folder, if you will, that represents a kind of um, atomic unit, if you will, like of a business concept or something, domain concept. Because I saw you said the adapter should be kind of be outside, right?
Outside. If there's any one rule, adapters are outside. That's like if you just hang on to that thought, you've got it, right? Because if an adapter's ever inside, it's wrong.
But what's the method for organizing those adapters? You know what I mean? I
Your
guess.
business, not my business. I'm very clear. Juan, it took him like 2, 3 years of asking me questions and watching me on Twitter, and I could say, not my business. And he go, come on, Alistair. I go, not my business. like make this look this, everybody's making a million decisions, right? I'm only gonna take two for you. One, you have to have the ports and you have to have the instance variables, no question. Everything else, everybody's got different personalities, philosophy, stuff like that. And I publish something and someone writes back and says, I have a better idea. And I go, that's cool, that's a better idea. And then somebody else says, no, I like the first idea better. And I go, man, just get those interfaces and just get those interfaces there, put the adapters outside. I'm so happy. Organize them anyway. You actually how do I arrange my adapters section of the book is one paragraph long. It basically says, same as for the other stuff, whatever you want, knock yourself out. Not my business, right? Now, when we look at people making mistakes, that's different, right? I can say, I have seen a lot of mistakes and I found that this is good advice. If you don't like my advice, that's, your business. So for example, I always, for years, put the interface declarations, the ports inside the app. So there's a folder project called app, and it has three things, right? Inbound, outbound, and app, right? I'll use inbound, outbound to give you guys some degrees of freedom on your naming. And then there's another couple of folders, another folder way out there, tests, and there's another folder way out there called adapters. Inside are two incoming adapters, outgoing adapters, right? Or driven. And this guy says, I don't like that inside the project because now I have to keep recompiling, including the whole app when I just want to change those things out there. So I want to put my port declarations outside the app proper. So now it's very clear the app depends on that interfaces and the adapters depend on those interfaces. Super clear, the most decoupling. And I went, you're right, I like it, I'll change it. And this other person goes, no, I like the first one better. And I go, look, you're already safe. Just give me those damn interfaces, right? And so on. So that's now at the level of experience and advice and a bit of personal philosophy, but adapters outside, far outside, and then you can decide on the port definitions if they're in with the business logic or in their own little space. Thank you, Daryl. You're the only person asking questions.
No, I can ask questions too, but I need to let people ask questions. Uh, I from my personal experience as well, is putting it outside is best because what happens is when you leave it in, entropy kicks in, and all of a sudden, coupling shows up in places they're not supposed to be there. And when you take it out and make it clear that that's the interface, so the port would be what in the Java world would be the SPI, the service provider interface.
I didn't bring up the terminology, but that's perfect. It is exactly perfect language, right? API and SPI. Thank you.
Yeah, well, that's the Java world internal definition of services. That's the right. So it's what works. It's what keeps things sane over long periods of time. And so what happens is, I would say people that don't want it outside are more than likely less experienced. They haven't seen what happens with especially as the number of the developers increase, entropy increases, and the messiness goes on, and it doesn't become clear anymore what was the intent.
And here's another thing that's not at all in the pattern, but again, just experience when I go around teaching it. The moment I separate the adapters into the driving and driven, or inbound, outbound, people just go, oh, that's so clear now. Like this costs like no energy. And you got all these interfaces being defined and they're neatly partitioned like this. And so for like near zero energy, people that's the one, people who know lots of things, they go, oh, I like that, right? That this is like, ooh, when they see that. So there's a lovely little tip there. All right, cool. So we're inside the hour.
I would say the observation, there's a pattern that gets used in different ways, but there's the initial definition of a gateway. So the gateway pattern, what this is an implementation of a gateway pattern. So the gateway pattern is intended when you have a third-party service, a database, or anything. you would do this when you want to have some decoupling to be able to test it and do everything associated with it. So it basically implements a gateway.
That's cool. What, I'll look that up afterwards. I don't have it, but I know that I was struggling, because remember, I did this out of duress. I was being forced to use things I couldn't stand. And so 2000, I had this drawn up, but I'm going like, this has to exist. This has to exist, right? And I was looking. And it wasn't until 2003 or four that I found a couple of patterns that kind of covered it. And I don't know if Gateway was one of them. So I'll go look at it, because that has to do with the right-hand side, whereas the pattern hexagonal architecture ports says it's non-directional, just says there's inside and outside in ports.
Right.
You
Right.
implement the right-hand side, it's the gateway pattern, or the strategy pattern, as I call it.
Yeah, exactly. So yeah, that is so what happens is, since the micro architecture thing went like crazy,
Yeah.
you know, it's been like over 10 years now. When people hear gateway, they think of the inbound request to the microservice. They don't think about the service service behind this behind. So but the original definition, if you look up, this is from the patterns from the patterns guy, Fowler.
Yeah.
So this is Fowler, and he talks about this about probably 15 years ago and calls it a gateway. When you have an external service, you put an interface on top of it, and
Yeah.
so you can abstract it out. So this is to me, how you implement that.
Got it. Very cool. All right, everybody. End of lunch.
This has been excellent, Alistair. I really, really appreciate it. Uh, I appreciate I think it's very clear. You have another presentation. It's out on the Google, on the YouTube also on this, and this presentation is not the same as that one. So I would encourage folks that want to know, to get
It's
background.
basically the same, but I try to say something different each time. So maybe, there's some extra words in here this time or that time that just help you coalesce it better.
Has more code centric than the other presentation.
Very good.
So if they see both, which I did, this is why I asked for you, because I saw it before. I was like, well, this is great. This is even better than the other one because it's more code example for the
Right.
developers.
Cool. Very good.
Yeah.
All right.
Excellent.
Publish this so I can link to it and share it around.
Thank you again.
Thanks. Bye, everybody.
Bye, everybody.